Section 5.4 deals with the slope-intercept form of a linear equation. We have two learning objectives in this section. We want to be able to define and explain the components of the slope-intercept form of a linear equation. And second, we want to use slope-intercept form of a linear equation to graph lines. So first, what does slope-intercept form mean? Well, it means exactly what the name suggests it means. This is slope-intercept form. And what you'll notice is that this slope-intercept form gives us two pieces of information. It gives us slope, which can be found by looking at m, and it gives us the y-intercept, which can be found by looking at b. So for instance, if I was to have a linear equation that looked like this, y is equal to 2x plus 1, I could look at this linear equation and say, all right, my slope is 2, since it is in the m position. So m, which is also the slope, equals 2. And then I can look at this 1 over here, and that is my y-intercept, which we call b. Now, here's the thing about the y-intercept. The y-intercept occurs when x equals 0. So if I have a y-intercept of 1, we can say that that happens at 0, 1. Because the y-intercept always happens where x equals 0. So my x value will always be 0. All right. So looking at this equation that is in slope-intercept form, I can say that the slope is 2, the y-intercept is 1. Let's go ahead and graph this equation. So y is equal to 2x plus 1. Like we just said, the slope is equal to 2, and my y-intercept, which is 1, means that I have the point 0, 1. So we like to begin with b, which is helpful, right? Because begin starts with b. Good way to remember it. So we're going to begin with b. We're going to begin with our y-intercept. Let's start by graphing our y-intercept. This one happens at 0, 1. So let's put a point at 0, 1. From there, we can use our slope, which is 2, which I'm going to rewrite as 2 over 1, because 2 over 1 is still 2, and that reminds me that I do need to run 1. I'm going to use that slope to find my next point. So from that y-intercept, I rise 2, and I run 1. And guess what? I can keep doing that. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. And now that I have more than one point, I could go ahead and graph this line. So we'll go ahead and do that. Using our straight edge, we line up the points and graph the line. So slope-intercept form gives us enough information to graph a line. Let's try another one. So I'm just going to come up with a random equation in my head. Let's do y is equal to negative 1/2 x minus 2. So looking at our equation, our slope is negative 1/2, which can be written as negative 1 over 2 or 1 over negative 2. But not negative 1 over negative 2, because then it would become a positive slope. And our y-intercept is negative 2, which means we have the point 0, negative 2. Let's go ahead and graph. We're going to begin with b. So we start by graphing our y-intercept, which is negative 2. And then from there, we use our slope to find our next point. Now, I could either use, like I said, negative 1 over 2. So I rise negative 1, run positive 2. Rise negative 1, run positive 2. Rise negative 1, run positive 2. Or I could have used this other slope, 1 over negative 2, meaning I rise 1, run negative 2. Rise 1, run negative 2. Rise 1, run negative 2. What you should see is it all ends up on the same exact line, so it doesn't matter which one you use. And I can go ahead and graph my line. So to graph a line using slope-intercept form, begin with your b, begin with the y-intercept, and then continue to find other points using the slope. One more thing in this section is we want to be able to find slope-intercept form given 2 points. Given 2 points. So let's say they give us 2 points. Let's say our 2 points are 1, 7, and 5, 3. And we want to write an equation in slope-intercept form. Y is equal to mx plus b. Well, as we discussed before, there's 2 pieces of information I need to find to write slope-intercept form. I need slope, and I need the y-intercept. Let's start by finding slope. So to find slope, we've talked about before that we have a formula, y2 minus y1 over x2 minus x1. So let's go ahead and use that formula to find slope. So in our case, our second y value is 3. Our first y value is 7. Our second x value is 1. Our second x value is 5. Our first x value is 1. I simplify this to get negative 4 over 4, which gives me a slope of negative 1. So that means for my m value, I can plug in negative 1. Now finding b is a little bit more tricky. Here's what we're going to do. We are going to take the equation we have so far, which is y is equal to negative 1 x plus b. I got that negative 1 from just finding the slope. And what we want to do is we want to solve for b, but we can't solve for b as is because we have y and x values that we don't know. But here's what we can do. We are going to take one of our points. I'm going to use 1, 7. And we are going to plug that in for the x and the y. Let's go ahead and do that. So for y, I plug in 7. That is equal to negative 1 times the x value I'm going to plug in, which is 1 from that same ordered pair, plus b. Now I have an equation with one unknown value, and therefore I can solve for it. Let's do that. So 7 is equal to negative 1 times 1 is negative 1 plus b. To get b all alone here, I'm going to add 1 to both sides, leaving me with 8 is equal to b. So I'm going to use that value now and plug that back into my equation I was looking for. So my final equation is equal to y is equal to negative x plus 8. Thanks for watching.